All right, my friends, if you weren't sure what to do with part C here, do not even worry about it. This is a really common type of question that they'll throw in as part of like FRQs on your AP exam, and really it's just a matter of practicing it a couple times to make sure you're good. So, so for part C, let's look at what we got for the fourth degree Taylor polynomial when we centered it at, or sorry, the fourth degree Maclaurin polynomial, which means it was centered at 0, but then when we plugged 1 in, okay? And so that, we were doing that here. That's what that was. So what I'm gonna do is I'm just gonna write the numbers out. And actually, let me back up. Before I do, let's talk about cosine of x if we had gone past the fourth degree term. So let's go back up here. You know, what do you think the next term would have been if they asked for like a higher degree than 4? You know, notice there's a pattern happening, right? So I could even be extra nerdy and swap that 1 out for x to the 0 over 0 factorial. And so notice that cosine has all even powers and all even factorials. And the signs alternate between negative and positive. So, so I would say the next term would have been x to the 6th over 6 factorial. And if I needed more, I could, you know, it would be really easy to build it up. Like once you notice the pattern, you know, I could be here all day showing off about how I could guess what the next terms were. So now that I've built cosine of x up with more terms, and you know, you could go forever if you want to make it perfect, but I've built it up with more terms. Let's look at, you know, when you put a 1 in there for x, you know, what did you get? Well, the first term is always 1 no matter what, and then the second term is minus 1/2, and the next term would be plus 1 over 24, I think we got. And then the next term would have been 1 over 720. And then the next term would have been 1 over whatever 8 factorial is. I don't feel like figuring it out right now. But this is what cosine of 1 would have been equal. You know, this is what we would have gotten for it had we, sorry, this thing's moving around so much. This is what we would have gotten for it if we had used more than 4 terms. Well, what I want you to notice, look at the way cosine of 1 looks when you expand it out. Notice that it is alternating in sign. So it is an alternating series. And then notice also that the non-alternating part of this alternating series could be defined as a sub n equals, well, the top is always 1 because we were plugging 1 in for x, and then the bottom is n factorial. Well, notice that that is always positive, that it is always decreasing in value, and notice that as n approaches infinity, the value of 1 over n factorial approaches 0, which I don't know why I wrote it like that. Notice that the limit as n approaches infinity of 1 over n factorial is 0. So what does that mean? That means that the cosine of 1 is represented as an infinite convergent alternating series. And because of that, we can use the alternating series remainder theorem. So when we figured out that cosine of 1 was approximately 13 over 24, we just used basically the first 3 terms. So the value of the first neglected term would be negative 1 over 720. And remember that the difference between the infinite sum and a partial sum is always, as long as you're dealing with a convergent alternating series, it's always less than the absolute value of the first neglected term. All right, so now we just have to say that. Okay, so I would say since cosine of 1, which would be exactly, I hope it makes sense, if you have infinitely many terms, we would have hugged that curve perfectly. So it would be exactly this. So 1 minus 1/2 plus 1 over 24 minus 1 over 720, etc. Since this is a convergent alternating series, we could say that the difference between actual cosine of 1 and what we got when we added up the first three terms is always less than the magnitude of the first neglected term. So the way you could say that in math speak is if you were to subtract cosine of 1 and remember we got 13 over 24 when we summed up the first three terms. Because I don't know which one's bigger, I'll just say the difference is what you get when you subtract them and then take the absolute value. So here's the difference between the real thing and our approximation, and it will be less than the magnitude of the first neglected term, which would be negative 1 over 720. And then if you simplify this, you'd end up with 1 over 720, which is less than 1 over 700. There we go. And that is how we know that the cosine of 1 is within 1/700th of p sub 4 of 1. Just a little throwback to the alternating series remainder theorem for you. All right, my friends, our last example that we'll think about today is going to be example 3. And I'd like for you to consider how would you go about finding a 4th degree Taylor polynomial for f of x equaling the natural log of x. See how it goes. Check in with me in the next video.